All right, and here's what our number 6 should look like for the homework.
Oh, come on, man.
Oh, you did y equals x instead of y equals. Oh, yeah, you flipped both of them. That y equals x should have been that one. Y equals x should have been that one. So the biggest issue that I'm seeing, it isn't performing the reflection itself. It's not setting up the problem correctly. Like maybe not plotting a point correctly or forgetting what one of these lines that we're reflecting in looks like. So use Desmos to set up the problem. Right? Plug the original information into Desmos so that you can see the original problem. See where the original points are and see what line you're supposed to reflect across. Then perform the reflection. Okay? Use Desmos to make sure that you have the original problem set up correctly. Okay? Any questions on the homework problems? All right. Then today we're going to talk about translations. Okay, it's transformations that we're going to do. We did reflections last week. Translations is next. So all a translation is vertically and or horizontally sliding a figure. So symbolically, okay, we're going to write a rule for each of our translations, okay? Or sometimes there'll be a rule written for us that just tells us take our original point and then we're going to add something to the x coordinate and add something to the y coordinate. So whatever number I'm adding to the x coordinate, in our generic notation, we're going to call that h, but whatever number we're adding, that just tells me how far left or right to go. Okay?
Like HK shifts?
Yeah, HK shifts, yeah. I mean, I think you did a little bit of those in algebra, right? Maybe, did you do quadratics with that?
Mm-hmm.
Right.
I did it.
What did I mean? Like, what? And that in algebra, we, last year we did
I don't remember that book.
I don't remember that.
I don't remember anything from algebra.
Something that
I had that teacher.
looked like this.
Last time I had an algebra
Oh, yeah.
class with my
Like a
freshman
like
and sophomore year.
Yeah, so I think the hermit crab was the,
That's how he
yeah,
kangaroos and hermit
yeah. Hermit crabs go left and right,
Then they were
kangaroos
on.
go up and down. Okay? I'm not too concerned with the actual h and k, because if we're adding a number to x, okay, x is the horizontal axis, right? So h would just represent the horizontal slide or horizontal shift, would represent the vertical slide or vertical shift. So if we just jump right into an example here, again, we always want to plot our original coordinates first. So if I plot Q, R, S, and T here, let's see, Q is at -6, -1, R, -3, +1, S is at 1, -5, and T is at -2, -7. So this is my original rectangle. And now this rule is telling me to go right 5, up 7. Okay? So for each coordinate, I'm just going to take each coordinate and go right 5, up 7. So this entire rectangle is just going to be shifted up here somewhere. Right 5, up 7. So I'm just going to do that for each individual point. So R, go right 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5, 6, 7. And our notation, right? We put a little prime on that R, and to show that that's our shifted point. And I'm just going to do the same thing for each coordinate. So Q, go right 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5, 6, 7. So that's Q prime. S prime, right 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6, 7. And finally, T, go right 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6, 7. So here is my figure shifted right 5, up 7. So fill in our new coordinate points here. So Q prime is at negative 1, 6. R prime is at 2, 8. S prime is at 6, 2. And T prime is at 3, 0. Okay, so graphically, right, this means just go right 5, up 7. But what we're actually doing is just adding 5 to each x coordinate and adding 7 to each y coordinate. Right? Negative 6 plus 5 is negative 1. Negative 1 plus 7 is 6. Right? So that's a good way of double checking that we're at the correct coordinates. Okay. Questions? Okay, let's take a couple of minutes and try a couple of these. Okay, we're not going to do all of them. Okay, because these do get pretty repetitive. Okay, so let's just try numbers 2 and 3. Okay, let's just do 2 and 3 here.
I'm an aerospace engineer. I'm an aerospace technician.
All right, take a look up here at numbers 2 and 3. Okay.
Dude,
On number 2, we took our original triangle and took each point left 3 and up 8. So we would end up here. And then on number 3, we took each original coordinate and went right 2, down 2. So our new rhombus is actually partially on top of the old one. Right? So we didn't move it that far. Just right 2, down 2. Any questions on translations so far? We're not done for the day. Alright. So go ahead and flip over your note sheet then. Okay, so on numbers 7 and 8 here, we want to write the rule. Okay, we're given our pre-image and our image, and we want to write the rule. So on this one, we just want to pick out one pair of corresponding points. So I can look at D and D prime. Now, which one's the original one and which one's the new one?
D prime is the new one.
This is the original, this is the new one, right? So we just want to start at our new one and figure out how far I have to go in the x direction and how far I have to go in the y direction. So the way that we're going to write the rule is just like they're presented on the front. I'm going to say xy goes to x plus whatever number and then y plus whatever number. So to get from D to D prime, I'm going to the right, 1, 2, 3, 4, 5, 6, 7. So I would write my rule as x plus 7. And then for the y's, I go up 1, 2, 3, 4 to get to D prime. So I would write that as y plus 4. Okay? So take 20 seconds and try number 8 here. Okay? Pick out a pair of corresponding points and write your rule like this. Okay? X plus or minus a number, depending on if you're going left or right. And y plus or minus a number. Okay? So make sure that you're starting and ending at the appropriate places.
Okay. I think the reason being is because the prime symbols come on.
Yeah, for the P.
I did it for the error.
Yeah. So, if we pick out a pair of corresponding points, okay, I picked P and P prime. This is my original point, and this is my transformed point, right? So to get from P to P prime, I'm going left 4. So I would write that as x minus 4, and then I'm going up 2. So I would write that as y plus 2. Okay. Any questions on writing the rule given a pre-image and an image? All right, then the last thing we're going to do today is combine reflections and translations into the same problem.
Oh, no.
Okay, so we are going to take some figure and perform 2 operations. So I'm going to reflect, in number 9, I'm going to reflect my original triangle and then translate it. So let's start by plotting our original points. So negative 3, 7 is x, negative 2, 1 is y, and negative 5, 2 is z. So here is my original triangle, and I first want to reflect that in the x-axis. So what's that going to look like? How do I do that?
The distance from the y-axis. So y is 1 from the
Exactly. I just want to take each point, see how far it is from the x-axis, and then go that same distance on the other side. So y is 1 from the x-axis, y prime will be 1 on the other side. Z is a distance of 2, so I'll go a distance of 2 to get to z prime. And then x is 1, 2, 3, 4, 5, 6, 7, so I'll go 1, 2, 3, 4, 5, 6, 7 to get to x prime. So here is my triangle reflected in the x-axis. Now I want to take this new triangle and translate it right 9 up 2. Right, so from each of these new coordinates, I'm just going to go right 9 up 2. So start with x, go right 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 1, 2. Now, since this is the second operation that I'm doing on this, I'm going to label this as x double prime. Okay? This is the second time I've transformed this point, so this is x double prime. So do the same thing with each of our other coordinates. Y, I'll go right 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 1, 2. And z, right 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 1, 2. So this is my z double prime. So this is my triangle after I've performed 2 transformations. Reflect in the x-axis, and then translate right 9 up 2. So we want to jot down our final coordinates. Now, these should have double primes on them actually. We want to write down our final coordinates, right? X double prime, y double prime, and z double prime.
So all of those mean double time? 9, 10, 11, 12?
Yeah. So let's see, x double prime, we are at 6, negative 5. Y double prime, we are at 7, 1. And z double prime, we're at 4, 0. Okay. Questions?
Do we have homework?
Okay, so go ahead and try number 10 here. Okay. Go ahead and try number 10, where we take our original parallelogram, reflect in the line y equals x, and then translate left 3 down 7. Okay, so I'll give you a few minutes to try this one.
Is this still recording?
I just started it. I paused it.
Hey, this is Josh. I found a battery on the floor. Hey, Eric, did that make you self-conscious about your allergies?
Thank you.
No, I usually always go out in the hallway to do it, but
I did.
Hey.
What's your name? What's your name? I'm on YouTube.
Imani?
What?
Imani?
Imani? That's all she wrote.
Let's go.
I have him on the video that has 226,300.
All right, let's take a look at number 10 up here. Okay, I believe some people were getting confused on the reflection in the line y equals x. Okay, that's just what we did on Friday, where we took each coordinate and counted the distance to the line y equals x, and then went. So if I went up from Q, then I would go left to get to Q prime. If I go up from R, I go left to get to R prime. So we should be able to see that if we were to fold across this line, these two parallelograms would match up. So then I take this new figure, and it tells me to go left 3, down 7. So we should end up down here somewhere. Okay, and then these would be our final coordinate points. Okay. Any questions on multiple transformation stuff? Okay, reflecting and then translating, or we could translate first and then reflect. No questions? All right, then